Uh, Good afternoon. We'll continue the earlier video about the check basins. Actually, I want to discuss this time with respect to FAO publication. A very quick estimation of some of the things you can see. Let us minimize this and try to. You can see. I think I have already mailed to this document earlier. So in this we can see various topics are there. I don't want to repeat all what has already been. Just I will go through the figures and some tables. This is how in a basin the rice is transplanted, and of course that we know. And then with respect to terraces, contour bending and then terraces making is also one idea how particularly why I am referring now is regarding this basin width, and then table 1 you can see this is a slope of the land. The maximum basin width somewhere in the range is an average figure, depends upon the slope. That means the slope is smaller, the width of the basin in meters you can see increase. For a greater slope, the width is for the greater slope the width is less. For a lesser slope, the width is greater. So that's what this publication refers to. Similarly, basin size, in the last slide before this video, when we are talking about with respect to the various soils, this is the stream size, liters per second, and then these are the various soils, and you can see the size of the basin in meter square. For example, the stream size small, and when the soil is very sandy, the basin size is very less. If it is clay, the basin size is bigger. So that is how. Here is an example how to estimate basin sizes. You can see estimate the dimensions of the basin when the soil is a deep clay loam and land slope is 1%. Given the land slope is 1%, as basin construction is mechanized, the terrace should be wide as possible. The available stream size is this much. So in this, the answer or design, the solution is from table 1. You can go to the table 1. You can see this is the table what we have shown. From the table 1, the maximum basin or terrace width of the slope for 1%, it is 25 meters. You can see here for 1%, it is somewhere maximum width is 25 meters. So similarly, for the next thing, that is uh, from uh, uh, from table 2, maximum basin size for a clay loam, that is given in the answer. It is, I mean, in the question it is given clay loam. So from table 2, the maximum basin size for a clay loam soil and an available stream size of 25 liters per second, that is given 25 liters per second here. Here you can see this is given. So from table 2, this is table 2, the stream size 25 somewhere here, nearer to this. So you can work out this clay loam around 1000 you see meter square. So the if the basin area is 1000 meter square and the width is 25 meters, the maximum basin length is this much, 40 meters. This is how a practical way of designing your field size. Some of the other intricacies, like shape of dimensions of the bunds, you can go through here. You can see uh, somewhere around 40 to 50 centimeters, or even permanent bund. Regarding permanent bunds, you can put up to almost 9 centimeters. Whereas temporary bunds, you can have width is 60 to 100. In the case of permanent, width is 1.3 meters to 1.6 meters. That's a bigger one. And this is a field level. Here, 10 to 15 to 30 centimeters height. So this is how the things are there. Of course, basin construction and all in civil engineering, you might have already done this one. But what I would like to say with respect to this, you know, uh, this of course construction terraces. I don't think not. I want particularly I want to show you about under irrigation and then over irrigation and all. And if the impermeable layer is this is wetting patterns, yeah, which I want to show you. Ideal wetting. That means if you just release the water, this is the root zone, and except a little bit here, by and large, the entire root zone, this is the root zone level, entire root zone, this is ideal wetting. Okay, so likewise, you have other after ideal wetting. Um, Poor wetting patterns can be caused by unfavorable natural conditions. Example, compacted subsoil. Sometimes in the irrigation they compact the subsoil so that not much water is being percolated down. Poor management. Example, supplying incorrect stream size. So you must supply a correct stream size. Okay, applying too little or too much water, that is also does not so nearly impermeable layer above which a perched water table is formed. This is one thing. Sometimes by compacting, a nearly impermeable layer is created and a perched water table is formed. There are advantages and disadvantages for this. For example, you see a compacted subsoil can sometimes occur in a basin some 30 to 40, 50 centimeters below the soil surface. Infiltration through this layer may be very slow. Water tends to accumulate above this layer. A perched water table is formed. This may result sometimes in waterlogging also. But this may be useful when water this layer is highly the natural soil is highly percolating. So the situation may be very helpful for growing rice, but will be harmful for other crops. So you should resort to when this method only when you are growing rice. The compacted layer can be removed by using deep ploughs or rippers, which break up the subsoil. So anyway, that is regarding the perched water table conditions creating, and then wetting patterns, poorly leveled basin. You can see poorly leveled basins. Sometimes if you don't level the basins, you can see this part is properly wetted, root zone, whereas here this not properly wetted, and again this part is even your percolation due to losses because it's not properly leveled. So the proper leveling is very much important in all irrigation methods. So a wetting pattern when the flow rate is insufficient. You can see all the water that is let out here is simply go on getting infiltrated here. Only root zone is up to this much. At this end, it is going beyond the root zone and water is wasted. Whereas at this end, you could not meet the up to root zone depth. So these are some of the intricacies you should observe when this is this discharge is very smaller. You must have a proper discharge. So wetting pattern when the flow rate is insufficient, then we will have under irrigation. You can see here under irrigation. Under irrigation as such is not bad, but to have to irrigate quite often. but the entire root zone is not wetted. So this is the problem. That's why frequent irrigation we have to increase. Frequently irrigation we have to make it. In fact, some water can be conserved under irrigation also. So that's why it is written there are no percolation process during under irrigation. Although water may be used efficiently by this approach, frequent irrigation will be necessary to meet crop water needs. However, continual under irrigation will eventually restrict root development. This is bad. Yeah, once in a while under irrigation is okay, but not always in the name of conserving water. Okay. So over irrigation, this is another thing. Uh, uh, this is too much water wasting. A lot of almost you are wasting to the equal to the amount of water required. So over irrigation not at all permitted. So this is how I would like to highlight some of these things here, and we will go for uh, you know other things like one more method. I think I have just small method I have here, that is called zigzag method. You can see in this zigzag method, it is a special method normally for this kind of uh, you know uh, tobacco and then chilies and other things. Very small plots are prepared. So it is a special method of flooding water. Takes circuiting route before reaching the dead end of each plot. So the whole area is divided into a number of square or rectangle plots. Each plot is then subdivided with the help of low bunds or levees. This method is suitable for a relatively level plot. Let us go for this actual layout. You can see layout of zigzag method. This main ditch, then water is diverted like this. Water is diverted like this, and then comes to this and again goes back. So to and fro like this. Again water is diverted like this. This method is mostly used for chilies, cash crops like tobacco, many such type of things. Okay. So this completes the almost, your check basin method. If you go back to your original classification of these methods, you can see the here we are, check basin, rectangular, contour, ring. A zigzag is another one. Then we go for this what is known as furrow methods. That's also very important. So I will stop here this video, and then we will go for this furrow method. Okay, later on. Thank you very much.